Okay, start from now. Okay, Bismillah ar-Rahman ar-Rahim. Today, inshallah, we are going to talk about the concept in the second learning outcomes, talking about the batteries. If we classify the battery, we will find the batteries are classified in two main types: primary, and the second one is called the secondary. Both of the primary and the secondary are the galvanic cell. What's meant by the galvanic cell? Galvanic cell is the cells that work, or the system work to change the chemical energy to electric energy. So we'll find the reaction is called the spontaneous. What's meant by spontaneous reaction? Producing electric current. So, what is the difference, or the main difference between the primary and the secondary? Primary, it's called the irreversible. What's meant by the irreversible? We can't recharge it after the material of the cathode are finished. Can't be charged, can't be recharged after cathode material, after the materials of anode or cathode consumed. But for the second type, we will find reversible. What's meant by reversible? Can be recharged. So we can reverse the reactions. Okay, let's talk about the examples. We are going to talk about the three examples. For the primary, we're talking about the mercury cell and hydrogen fuel cell and the third side we are going to talk about the dry cell battery. What are the examples that we are going to talk about it in the second show? We are going to talk about the lead acid battery, lead acid battery, and we talk about lithium ion battery. Okay, firstly, for the mercury cell, what is the value of the electric current that producing from our mercury cell? EMF equal 1.35 volts. The value of the EMF for the hydrogen fuel cell, EMF for this cell, 1.23 volts. What is the value of the EMF for the dry cell? EMF or E for the cell, 1.5 volts. For the structure of the mercury cell, we will draw the structure. We don't need the drawing the structure, since you know that your questions is MCQ, but I won't draw it. Mercury cell is one of the cells that's used in earphones, calculator. It is a small compacted one. Can't be opened since the mercury that found inside it is a toxic material. So firstly we are going to talk about the anode. The anode made up of zinc anode. And you know in the galvanic cell the anode is a negative. And what about the cathode? the cathode, it will be the mixture from the mercury oxide plus graphite. Graphite in this case will work like grease to keep the moisture of the cathode material. And we will find the electrolytic material is made up of the KOH. We are going to talk about the reactions that are taking place in this cell. So the reactions will be as follows. Zinc plus HgO will produce to us zinc oxide, ZnO plus Hg. So zinc converted into zinc oxide, it will be an oxidation process taking place for it. Mercury oxide converted into mercury, the reduction process taking place for it. It is a toxic material, so we can't open it. It's making the compacted to keep it away from the children, since the mercury are reduced are a toxic material. Okay, let's talk about the hydrogen fuel cell. Hydrogen fuel cell structure will be consisted from the two partitions. These two partitions, the partition at which the material of the anode are entered inside the cell. So we will find the hydrogen representing the anode. Excess hydrogen out from this orbit. Separated between the anode and the cathode. Cathode representing the oxygen. In this case, we will find what is the excess amount of oxygen plus water. KOH, it is representing the electrolytic material, and this cell is producing electric current that can be used for lighting. This type of cells that use inside the hydrogen fuel cell is used inside the spaceship as it is a source for the electric current or the source of electricity and the source of the drinkable water for astronomers. At which the reaction taking place, the hydrogen gas is pushed from this position through the electrolytic material react with the oxygen. So we'll find maybe the excess oxygen is out and the water is out. If we're making the small prototype from it, we'll find the droplets of condensed water vapor at this open. Not we'll find the water like the water is pulled from the tape, but we'll find the small droplets for the small model. Okay, what is about the reactions? We will write the reactions to can keep it as a follows. Firstly, 2H2, O2, 2H2 plus O2, giving to us 2H2O. We're taking the 2H2 in this side, so it will be 2H2O plus 4 electrons, giving to us 4OH. Taking to this side, it will be 4OH negative, giving to us 4H2 plus 4 electrons. Okay, these reactions are taking place at the anode, anodic reaction, and this is the cathodic reaction, and this is the total reaction, total. So firstly, 4OH, 4OH can be firstly we will find the rod. This rod is made up of the carbon representing the cathode. The electrolytic material consists from the two parts. Firstly, the material of the anode is the zinc case, the body of the cell, zinc anode. But the anode in the hydrogen fuel cell is the hydrogen, and the cathode is the oxygen. Anode is the zinc case. carbon root represent the cathode. Cathode is positive, anode is negative. Then we'll find the electrolytic material between them separator. When you open this cell, you will find the zinc case, then we'll find the moisture paste, then we'll find the separator, like the paper, between this paste and this paste, but it's semi-permeable, allow the movement of the material and the electrons. So we'll find black paste and the white paste. What is the structure? We will find the white one consists from an H4Cl plus zinc chloride. And the black one consists from what? The black one consists from manganese dioxide, ammonium chloride ions, and fragmented carbon. If we are going to talk about the reaction, what is the type of the reaction, the total reaction taking place in this cell? We will find the zinc react with NH4 positive part and MnO2, manganese dioxide. We will find, firstly, the zinc are oxidized, so it will change it to Zn positive 2. Then, NH4 will divide it into NH3 and H, but we'll put the balance for the equation. So, one from the H are react with the MnO2. So, firstly, we'll find NH3, the ammonia is formed. Then, we'll find MnOOH2. This is the last compound are formed for this cell. After the period of time, we will find the dryness taking place for this paste, and we will find the materials consumed now in this case, since we will find the moisture are lost. After the moisture of this paste are lost, we will find the reaction will stop. Now we are going to talk about the secondary cells, the cells that can be recharged again. So we'll start firstly by lead acid battery. Lead acid batteries consists from partitions. So 1, 2, 3, 4, 5, 6. 6 sheets. And both 1, 2, 3, 4, 5, and 6. Collect it represents the anodic material. It is the poles of lead. Anode. Negative. Cathode. Collected lead oxide, BbO2, cathode, positive, and we will find opening or the cover. What about the electrolytic material inside this cell? We're talking about the electrolytic material. Electrolytic material consists from the conch sulfuric acid, H2SO4. What about the density of this liquid inside this cell? We will find the density are range from 1.28 till 1.32 gram per million. If the density of this liquid change inside this battery, the reaction may be stopped. So we can add it from this cover, open this cover and add the lid. If the partition of the cell are not as affected or not defected, we can add the acid if the density of the gas or the acid inside the battery are changed. From where we can determine that the density of the liquid inside the battery are not correctly or it's not suitable, we can use the device called hydrometer. If the density of the liquid is changed from this range, we'll find the reaction is stopped. We can using the density of the liquid inside the battery by hydrometer. Hydrometer device or apparatus used to measure the density of liquid inside the battery. Let's talk about the reactions. What's happened in the reaction? The total reactions and what is the value of the E for this cell. The value of the total E for this cell E equal, we have 6 partitions, multiply each partition by 2, it will be the 12 volt. Okay, what is about the reaction? Firstly, we'll start by lead plus lead oxide. Then, when I have the 2 molecules from the sulfuric acid, 2 molecules giving to us 4H positive plus 2SO4 negative 2. The reactions will move in the 2 directions. First is called the discharge. Discharge means I obtain electricity from it. And the other side is called the charge. We will find Bb is O4 plus 2 water molecules are formed. Firstly, when this charge is work as a galvanic cell, the anode is the negative and the cathode is the positive. But in the case of the recharging it or the charging, we will find the poles are opposite. Means that it will be as an electrolytic cell. So the anode, it will now inshallah we are going to talk about the last one. The last example is talking about the lithium-ion battery or the mobile battery. In the mobile battery, we will find it consists of the 2 partitions. It will be compacted and it will be maybe flat. Firstly, the anode represents the lithium hexacarbide. Lithium hexacarbide. So, it is the anode, and in the anode in the galvanic cell represents the negative pole. And lithium cobalt oxide, it represents the cathode. Lithium cobalt oxide. The question now, Mr. O and O2, maybe O3. It's not O and O2. It's cobalt, and the symbol is cobalt is the CO. So we'll find carbon is the capital and oxygen is the small. Okay. Firstly, what's happened? During the discharge, obtaining the electricity from it, when you're doing or playing at the mobile, or working on mobile. Firstly, the lithium changing to lithium ion, losing an electron. This electrons move from the anode toward the cathode, toward the cobalt oxide, and react with it. It is in the case of what? So the lithium carbide giving to us lithium ion and the 6 carbon atom with electrons. Electrons move with the external circuit. This is in case of discharge. But in the case of the charging, when you connect your mobile with the charging, the poles are opposite. So we'll find in this time cobalt oxide. Cobalt oxide is work at the anode, and the anode is the positive. So we'll find the lithium ion liberated again from lithium cobalt oxide. We will find the lithium ion liberated again, and the electrons move from the anode toward the cathode toward the 6 carbon atom, forming lithium carbide. Cobalt oxide with the lithium ion plus an electrons giving to us lithium cobalt oxide. What is about a total reaction? Lithium carbide and lithium carbide. Cobalt oxide, and electrons, neglected was electrons, and the lithium ion, neglected was lithium ion, lithium cobalt oxide, and 6 carbon at the end of this reaction. Firstly, when you start to recharging, you must start or choose the suitable chargers to connect it with the battery during the charging to not make it burn. It is our lesson today, and it's finished. See you soon.